The Atari 7800 was an underrated system. Using one today presents some modern problems. The only output is RF. We'll fix that with this kit from the future was 8-bit. Plus a power connector that's rarer than Rocking Horse Road apples. But we're going to address these annoyances right now.
Mark fixes stuff.
The Atari 7800 was eventually released in 1986 to compete with the NES. In response to criticisms levelled towards the Atari 5200, the 7800 became the first ever video gaming console to have built-in backwards compatibility, playing not only 7800 titles, but most of the huge library of Atari 2600 games. Experts might note that this fascia is not usually seen on the PAL 7800, and you'd be correct. Indeed, this is a North American NTSC model. As such, the RF output of this console will be incompatible with a UK TV anyway. The power is just 9 volts DC, so we'll only need to replace the proprietary jack with a barrel connector. It's not a direct replacement, so we'll have to be a bit inventive. Inside the kit from the future as 8-bit we have a cable with a quad-pole 3.5mm jack plug. This carries the video and audio signals to a yellow RCA connector for video and red and white for audio. There's a generously lengthy set of wires, ending in a plug that will interface with the mod board. Finally, inside this anti-static bag, we have the mod board itself, along with a double-sided sticky foam block. The board is very compact and seems really well made and tidy. Let's get it installed. I use a soft cloth to protect the console from any further scratches when I flip it over. There are 5 screws holding the 7800 case together. And they're all the same size, so they can be kept together. Once the screws are removed, the top half of the case simply lifts off and can be put to one side. Next, we can see the metal twist tabs along each side of the RFI shielding. These can be a pain to undo. There's 2 hidden behind the cartridge slot as well, so don't miss those. I'm going to use my tab twiddler. In reality, it's a wire wrapping tool, but really does work for this kind of task. Slipping it onto the tab is the hardest part. After that, working the tool left and right straightens and untwists the tab. I won't show every tab because they're all the same. With a bit of wiggling, the RFI shield comes off. This is the area we will mainly be working on with the Composite mod. To do that, we need to get to the underside of the board. Bear in mind that there's a second piece of the RFI shielding on the underside of the board. This should come off pretty easily now that all the tabs are straight. Of course, no mod would be complete without a dead bug. Rest in peace, my buggy buddy. We need to remove a few components, like this coil here at L2. We also need to remove resistors R5 and R6, as well as resistor R3. The transistor at Q1 will also need to be evicted, as well as the modulator can. Let's power on the soldering iron. And get the desoldering gun ready as well. We'll remove the modulator can first. We'll need to desolder these 4 points, and the 4 soldered anchor points on the underside of the board. These will take a lot of heat, but the 4 pins will be easier. Just the desolder gun alone doesn't melt the post solder even at 460 degrees Celsius. But the iron and the desolder gun used together make short work of the joint. I use the same process for the other 3 posts. For the signal and voltage pins, I turn the desolder gun back down to 330 degrees. With the pins desoldered, we can try and remove the modulator. Rocking the can gently shows that these 2 posts are still partially soldered. Heating the pins with the iron whilst pushing disconnects them. Then the modulator comes free. It will be archived with the machine. With the modulator gone and the signal points clear, it's time to remove the transistor at Q1. Again, the desolder gun makes short work of the 3 legs. Except I've made a mistake and desoldered the leg of the wrong component. I quickly resolder that leg and move on desoldering the correct leg. The transistor simply dropped out of the board. Time to get the coil out of the way. It's soldered at these 2 points. The coil comes out with minimal resistance. Again, this will be stored. These resistors are the last things to be removed. The desoldering station is a real time saver. With the solder gone, I just have to wrestle the bent resistor legs out of the board. All the required components are now removed, so it's a good time to place the mod board onto the PCB. The jack socket needs to be in the middle of the 2 post holes to line up with the hole in the case. Using the sticky pad supplied, we carefully affix the mod board into place. It sticks really well and seems very securely stuck. I'm going to put the cable into place and cut the wires to a more appropriate length. The white wire needs to be connected to the vias for both R5 and 6. Let's snip it about here. Next, I'm going to strip the wire and solder it into the board. We can bridge the 2 points in a moment. This is a piece of component lead out of my scrap bin. I'm going to use it as a simple shunt to bridge the wires of R5 and R6. Now we'll do the red, yellow and black wires. First we cut them to length, and then strip them. This wire really takes the solder well, so I'm not pre-tinning the ends this time. With the wiring in place, we flip the board over and solder them into place. I'm pretty happy with the results here. Quite tidy with no excess cables. Let's turn our attention to the power socket next. These sockets are a real pain if you don't have an original PSU. We need to desolder these 2 points. A quick wiggle shows the socket is now loose. It's now simply a matter of unclipping the plastic supports, and this socket can be stored for posterity with the other parts. The standard barrel connector is not a natural fit. Instead, we'll be mounting it upside down with some hot glue and a cable tie. If that sounds a bit janky, well, it is. But it means no case drilling. Also, the barrel connector is a perfect fit in the case hole. This lends it even more support. The holes either side work well with the cable tie. First, a quick sanity check on which connection is which. The meter shows us that the left pad is positive and the right pad is negative. I cut some wires. This time I'll strip and then tin the wires. For this project I'm using leaded solder. It's a 63 to 37 tin to lead alloy and has a flux core of 1.8%. When working on retro electronics, it's important not to mix newer lead-free solder with older leaded solder joints, or problems can occur like fragile or cracked solder joints. Regarding environmental impact, we'll be keeping this machine running and out of the waste process, so for me at least, that's a net positive gain. We pop the black cable in the negative hole, and slip the tip of our red one into the other hole. Then soldering our pre-tin wires makes for excellent joints. I've checked the connections on these two tabs with the meter, and both are connected to the outer sheath of the socket. So we're just going to cut this one off. Snip snip. I'm just going to pop the board back into the lower case so we can get the alignment of the socket perfect when we hot glue it into position. It's like they were made for each other. We'll apply the glue to the socket and place it into position. We reinforce the socket with a nylon cable tie. It's not the most beautiful install, but it did avoid case cutting. I'll use a bit of shrink tubing as well, mainly because I like shrinking it. I want to use a center negative power supply with this console, like the one used on the Sega Mega Drive Mark I and the Sinclair Spectrum. Therefore, I'm connecting negative to the end connector for the center pin. The remaining pin is naturally connected to the other solder tab for the outer barrel connector, which will be positive. I really do love shrink tubing things. Okay, so in theory, that should be working now. Before we finish, let's quickly replace these capacitors from 1986. They've definitely earned retirement by now. Desoldering these is quick and simple. These are 2200 microfarad caps, rated for 16 volts, made by Wang's Cap. Wang. We'll replace it with this Panasonic part. You'll notice it's rated for 50 volts. Going higher on the voltage is usually okay, although the capacitors tend to get larger as their voltage range increases. Of course, you will need to match the microfarad characteristic properly. In the middle of the board, we find another Wang to pull off. This one is a 220 microfarad 16 volt part. We'll use this 35 volt Panasonic replacement. The old caps may well be fully functional, but seeing as they're over 3 decades old, it's worth replacing them. With the first 2 caps replaced, there's only one Wang left untouched. Again, this is a 220 microfarad 16 volt capacitor, and we'll use the same type of replacement as before. Capacitors have a longer positive leg and a shorter negative leg. Boards are usually marked to help you, like this positive indication printed here. On some boards the negative terminal is marked, so take care to get the right orientation. A quick snip, and the recap is done. So we've installed the Composite mod board. We've replaced that awkward connector, and we've pulled out all our Wangs. Time for a quick test. I'll pop it into the case to see if everything lines up. Then disaster strikes. It turns out that the positive tab connection I used is push to break. This means that with the plug in it, it disconnects the circuit. I need to tack the wire onto the middle connector. I left enough tabs sticking out, so it's no problem. The wire resoldered on fine, and I reinforced it with a touch more hot glue. The power now turns on. Great! Let's check out the picture. Oh. The supply cable is a touch too wide to go into the case hole. To avoid cutting the case, I'm going to slim down the soft plastic of the plug. You can get slimmer versions of these cables easily. Okay, I've quickly trimmed this down to test. It looks ugly, but it fits great. With everything hooked up, Winter Games fires up first time. Let's put this back together. I'm using an anti-static brush to dislodge any dust. Then we can use the vacuum to suck it off. I hope you're enjoying the video. If you're in a position to help support further videos, I would be honoured if you would consider becoming a patron at patreon.com/MarkFixesStuff. You'll get early ad-free access, as well as other benefits. Some people say not to bother replacing the RFI shielding, but for me it's a part of the machine and should be reinstated. For the same reason, all removed components will be bagged up and kept with the machine. I'll give the unit a wipe down with some window cleaner sprayed onto a cloth to remove any grease or dirt. Window and glass cleaner is safe, water-based and shifts much more dirt than isopropyl alcohol. It's also less likely to affect coloured decals or printing like the rainbow stripe on the fascia. When reassembling old and vintage equipment, remember to back off the screw until it drops into place. Simply position the screw in the screw hole and slowly turn it anti-clockwise until you feel it drop into the existing thread. By doing this, the screw will go back in easily and not cut a new thread, weakening the screw post and causing damage. After cleaning, I like to wipe down the case with a cloth that's been lightly sprayed with a silicone polish. Popping the AV cable into our new mod, and the power into our new jack. It's time to test. We'll use Ball Blazer to check the pokey sound is working. Big thanks to Steve Green for the loan of everything today. I've avoided the awful 7800 gamepad though, and I'll be using my Retro Radionics Arcadia microswitch joystick to play. In the words of He-Man, I have the power. Ball Blazer sound and music work great, and this game seems really technically advanced for 1987. I think the mod gives good quality video and audio as well. Winter Games is another title from '87. I did notice that the TIA sound is quite a bit louder than the in-cartridge pokey sound of Ball Blazer. I'm not much for sports games, or sports at all for that matter, but I do enjoy this game. It's a subtle change on the waggle 'em up genre, and it's tweaked to be sensitive to both direction and timing. True to form, I suck at it. Finally, no test would be complete without trying one of the plethora of 2600 games. We're going to test with Defender 2. Just to note that any flickering or screen patterns you're seeing are a result of filming and not present in actual play. I actually forgot I was filming and recorded about 35 minutes of this. It's such an immediate and playable game. My thoughts on this project? Well, we went from no power and NTSC RF only to an easy to hook up and play console. It's a thumbs up from me, but what do you think? Mark Fix's Stuff is driven by its generous patrons. Here they are on the screen. You can join them at patreon.com/Mark Fix's Stuff. Thank you so much for watching my video. Perhaps you'd like to watch some more. Here, I'll put some on the screen for you.